Hey guys, in this lesson we would understand how to determine the value of an angle when we are given its corresponding trigonometric ratio. That means if we are given a ratio cos theta is equal to root 3 over 2 and we are asked to find out for what angle theta is this cos ratio going to be root 3 over 2. Along with this, if we are also given the domain of theta in which it lies between, and if that is 0 to 2 pi, then how do we solve this type of a question for theta? Before doing the steps for the question, let's first understand how angles and trigonometric ratios are related to each other in the unit circle, and what is the meaning of this theta lies in between 0 and 2 pi, and how is this going to be used in order to find out the theta value. Let's say if we want to find out the value of sine pi by 4, we know pi by 4 is going to be the theta angle in this case. And in order to find out the ratio, we have to use special triangles because for pi by 4, pi by 3, pi by 6, we have special triangles. So we need not use calculator in order to find out the ratio of this. Sine is opposite over hypotenuse. Both of these angles are pi by 4, so we can use any one of these. Opposite of pi by 4 is 1 and hypotenuse is root 2. Therefore, the ratio that we get from the special triangles is 1 over root 2. Now, important thing here to note is that these special triangles work for the angles that are acute, or the angles that lie between 0 to pi by 2. Or if we talk in terms of unit circle, then the angles that lie in the first quadrant. That means we can use special triangles for angles that lie in quadrant 1. Now, how do we find out the ratios of the angles that lie in quadrant 2, quadrant 3, and quadrant 4? Because the unit circle runs from 0 to 2 pi, and let's say we consider pi by 4 and we draw it on this unit circle using the terminal and the principal arm. So this would represent pi by 4 angle, and the sine ratio for that is going to be 1 by root 2. Now always remember that the same sine ratio, 1 by root 2, would also exist in the second quadrant, third quadrant, and fourth quadrant when the terminal arm is going to reach the second, third, and fourth quadrant respectively, making a related acute angle of pi by 4. That means if the terminal arm is now in quadrant 2, making a related acute angle of pi by 4, the sine ratio of pi by 4 is equal to 1 over root 2. So will be the sine ratio of its corresponding theta or the principal angle. In second quadrant, we know theta is equal to pi minus beta, and beta here is pi by 4. We make the denominators common and we get here theta as 3 pi by 4. So remember, sine pi by 4 is 1 by root 2, so as sine 3 pi by 4, because that will also be equal to 1 by root 2, as 3 pi by 4 gives us the same related acute angle. Similarly, if you're in the third quadrant, this is beta and this is theta. Beta is still pi by 4 because we're working with pi by 4 angle. Theta for third quadrant is pi plus beta. So pi plus pi by 4, making the denominators common, would give us 5 pi by 4. Therefore, we can conclude here that sine pi by 4 is 1 by root 2, as well as sine 5 pi by 4 is also 1 by root 2. Similarly, if now the terminal arm is in the fourth quadrant, then this is beta and this is theta. Then theta will be equal to 2 pi minus beta. Beta is pi by 4 because we have been working with pi by 4. Making the denominators common would give us 8 pi by 4 minus pi by 4, which is 7 pi by 4. From here we can conclude that sine pi by 4 is 1 by root 2 and sine 7 pi by 4 is also 1 by root 2. So now we notice that in the first quadrant, sine pi by 4 is 1 by root 2. In the second quadrant, sine 3 pi by 4 is 1 by root 2. In the third quadrant, sine 5 pi by 4 is 1 by root 2. And in the fourth quadrant, sine 7 pi by 4 is also 1 by root 2. That's all is summarized here. This is for the first quadrant, this is for second quadrant, this is for third quadrant, and this is for fourth quadrant. We notice that the ratio values are going to be same for the related acute angle and the corresponding principal angles in different quadrants. However, the difference is the difference in the sign. Sign is plus or minus sign. Now we know according to cast rule, all values are positive in the first quadrant, sign values are positive in the second quadrant, and tan values are positive in the third quadrant, cos values are positive in the fourth quadrant. Sine pi by 4, because pi by 4 lies in the first quadrant, is going to be positive. Sine 3 pi by 4, because 3 pi by 4 angle lies in the second quadrant, is also going to be positive. However, sine 5 pi by 4 that lies in the third quadrant and sine 7 pi by 4 that lies in the fourth quadrant would have negative 1 over root 2 ratios. So that means for every angle and its corresponding principal angle in different quadrants, the ratio occurs 4 times. 2 times it is going to be positive and 2 times it is going to be negative. That depends upon the cast rule. Now, why do we need to know all this is, if we were given the question to find out angle theta for which sine theta was given to us as 1 over root 2 and the domain for theta was given to us from 0 to 2 pi. 0 to 2 pi means we have to take the entire unit circle and we have to find out which theta is going to give us 1 over root 2 ratio without any sign, means it's a positive sign, and we notice here that there'll be 2 such angles that will be giving us a positive 1 over root 2 ratio. One is theta will be lying in the first quadrant and that is pi by 4, and the other one theta will be lying in the second quadrant, that is 3 pi by 4. Now in order to get these thetas from the given ratio, we need to follow few steps, and for that we will be going over certain examples. This all was just to understand that we would not leave theta with one answer. We would leave theta with 2 answers if the domain is given to us as 0 to 2 pi. Now the question says calculate the radian value of theta to the nearest hundredth where theta lies in between 0 and 2 pi, and we have to find out theta for tan theta equal to 5 over 12. As this ratio of 5 over 12 does not lie on the special triangle, so we would use a calculator for solving this. And the steps that we have to follow in order to find out theta are as follows. Step 1 is to isolate theta. How do we do that in this case is, we leave theta on one side and we move this tan on the other side. This would give us tan inverse of 5 by 12. And when we put this on the calculator, we get theta is equal to 1.49 radians. Because we are supposed to calculate the radian value, make sure the calculators are in radian mode so that the values that we get are also in radian units. Now always remember, whenever we take inverse of a ratio to find out theta, the calculator would always give us the first quadrant angle. So this theta is theta that lies in the first quadrant, or in the first quadrant, theta is also called beta. Now, if we were not given this domain, then this would have been the final answer and we would have stopped here. Since we are given the domain that theta should lie in between 0 to 2 pi, that means we have to consider all the angles that would give us the ratio tan theta equal to positive 5 by 12. We know tan is positive in the first and the third quadrant according to cast rule. So that will be our second step, that is to identify the quadrant that would give us the same trig ratio. Because we are looking for no sign trig ratio here, no sign means no positive or no negative sign was given. That means it is a positive sign. So we are looking for tan ratios to be positive 5 over 12 that would lie in the first quadrant and the third quadrant. So in this case, that quadrant is quadrant 3. Next step is step number 3, where we have to use the relationship between principal angle and related acute angle for the quadrant obtained in step 2 to find the second answer. In this case, because we are in quadrant 3, and in quadrant 3, the relationship between theta and beta is theta is equal to pi plus beta, that we have learned in one of the previous lessons. Now when we use this relationship, we would get theta of the third quadrant, and that's what is going to be our second answer. Pi is pi. Beta is going to be 1.49 radians because the step 1 answer was theta 1 or beta value. So we use here 1.49 radians. Now As we are using calculator, remember that the pi value can now be written in terms of numbers because beta is also given to us in numbers. So whenever we are using calculator, we can use the pi as 3.14, we can use 2 pi as 6.28, and on the unit circle as well, we can use the range as 0 to 0.5 pi can now be found out using calculator by multiplying 0.5 with 3.14, and that would be equal to 1.57. So the first quadrant range is 0 to 1.57 in decimals. Second quadrant range is 1.57 to 3.14. Third quadrant range is 3.14 to 4.71 because that's what is equal to 1.55. And the fourth quadrant range is 4.71 to 6.28, that is equal to 2 pi. Now coming back to this problem, 3.14 plus 1.49 is equal to 4.63. Therefore, the two answers that we got is one from the first quadrant, and that is equal to 1.49 radians. And the second answer is from quadrant number 3, and that is theta equal to 4.63 radians. So for both 1.49 radians, the tan ratio is going to be positive 5/12, as well as for tan 4.63, also the ratio is going to be positive 5/12. Let's do another example for the sake of practice. Let's say the second question is cos theta is given to us as negative 1 over root 2. Find theta where theta lies in between 0 and 2 pi. Now here we have to notice that this ratio is given to us as negative. So when we use the cast rule, cosine is going to be negative in the second and the third quadrant. Therefore, this theta that we are looking for should lie in the second quadrant and third quadrant. Also, we notice that this ratio 1 over root 2 lies on the special triangles, and 1 over root 2 would come from this special triangle because 1 and root 2 values are present on this triangle. Therefore, we need not use a calculator for this particular question. So in this type of a question, step 1 is, these steps are going to be followed when we have the ratio given to us is with a negative sign. If the ratios are given to us with a positive sign, then we follow the steps explained in the previous example. Here, step 1 is to rewrite the question in terms of related acute angle, because related acute angle is the one that is going to always help us find the values of theta in different quadrants. So here we can write on cos theta as cos beta. However, always remember, whenever we rewrite the question in terms of related acute angle, the ratio becomes positive, because the related acute angle ratio is always a positive ratio. Therefore, we have cos beta as 1 over root 2 with a positive sign. Step 2 is to isolate beta. This beta would be equal to cos inverse of 1 over root 2. We can either use a calculator for this step. If we use a calculator, we would get the answer in number radians, as we got in the previous example. Because this ratio lies on the special triangle, we can also use special triangle to get this angle. So we are looking for which angle is adjacent 1 and hypotenuse root 2. Because cosine ratio is adjacent over hypotenuse. So for which angle is adjacent 1 and hypotenuse is root 2, angle is pi by 4. Therefore, the beta value is equal to pi by 4. Step number 3 is use the beta value to obtain the required thetas using beta and theta relationship for the corresponding quadrants. Since we are looking for quadrant 2 and quadrant 3 answer, we know theta for quadrant 2 is equal to pi minus beta, and theta for quadrant 3 is equal to pi plus beta. Beta that we have obtained is pi by 4. So theta in the second quadrant is pi minus pi by 4. That is equal to 3 pi by 4. And theta in third quadrant is pi plus pi by 4. That is 5 pi by 4. And these are our two solutions for this particular question. Another type of question that we have is, given the point -12, -5, we are supposed to sketch the angle. This is our unit circle and this is the coordinate grid. We have a negative x and a negative y value. So that means this point should lie in the third quadrant where we have a negative x and negative y axes. So let's say the point lies somewhat here. We connect the point with the center of the circle. This will form our terminal arm. The principal arm always stays on the positive x-axis. So this would be our principal angle. So when they say sketch the angle, they're always talking about the principal angle. And the coordinates for these points are -12, -5. Determine the value of r. That's the second type of question that can be asked from this problem. Now to determine the value of r, what we have to do is we have to take this point and extend it towards the x-axis. The point is always extended towards the x-axis in order to complete the triangle. So remember, the x value of this triangle is going to be equal to the coordinate value of the point, that is -12, and the y value would be equal to the coordinate value of the point, that is -5. R means the radius of the circle, and we know this terminal arm length is going to be the radius of the circle. As this forms a right triangle, in order to find out R, we can use Pythagorean theorem, and R would be equal to square of -12 plus square of -5 whole square root the whole thing. We get 144 plus 25 square root, and that gives us 13. Therefore, this radius of the unit circle is going to be 13 units. Next part of the question asks us to determine the primary trig ratios for this angle. We know angle is theta. Primary trig ratios are sine, cosine, tan theta. Sine theta is going to be opposite over hypotenuse. That is going to be -5/13. Cos theta is going to be adjacent over hypotenuse. That is -12/13. And tan theta is going to be equal to opposite over adjacent, that is -5/-12 or 5/12. And we notice that since this point or this terminal arm lies in the third quadrant, tan value is going to be positive, sine and cosine is negative. Last part of the question wants us to determine the theta value to the nearest hundredth. We can take any of these three ratios to find out the theta value, but always remember the best is to take the positive ratio. Since we know tan theta is 5/12, to find out theta, we would have to isolate theta, and we would put in the calculator tan inverse of 5/12, and that would give us 1.49 radians. This is not the final answer because the calculator only gives us the first quadrant angle. Whenever we take inverse of any trigonometric ratio, we get the first quadrant angle from the calculator, and that value is beta. We notice here that our theta lies in the third quadrant, so we would use this beta to find out the answer, that is theta in the third quadrant, and the rule is pi plus beta. So we would do pi plus 1.49, pi is 3.14 plus 1.49, and that would be equal to 4.63 radians. Therefore, this is our final answer for theta. And this is how we solve for theta or these types of questions when we are given trigonometric ratios or we are given coordinates of the points that lie on the unit circle.